Okay, this video is about planar functions. And when we have functions, usually we have values that run along what we call the abscissa or horizontal axis of a plane. We take the values lying along the horizontal axis of a plane, put it into a function, and the result are values that run along the vertical axis of the plane, or what we call the ordinate axis, the vertical axis of the plane. And we represent a curve. We draw a curve on our little picture to represent the intersection of the values that go into the function lying along the abscissa, the horizontal axis, and the resulting values from the function lying along the vertical axis, the ordinate axis. Okay, so the values that go into the function, we call that the domain values, and the resulting values we call the range values. And domain versus range, those intersect in some kind of curve. Some kind of curve represents the intersection of those values. What I've drawn here is, for example, a sinusoidal curve, say that we might find a sine function. So sine function or cosine function would be like that. But anyway, anything occurs like that. Okay, so that's how we might represent function values going in the domain values, values coming out the range values, and we plot where they intersect on a plane. Okay, but what we could do also is use all the values in a given plane and put those through, crank those through some kind of function, and the results would be also points on a plane. Now, if there are any points on a plane that for some reason couldn't be part of the domain, we would draw a little circle, or whatever. We would draw indicate some area where the values in the domain plane would not apply. But for those values that do, we could draw arrows mapping a point in the domain plane onto some point in what we call the range plane. That would be the plane that has the outcome or the answer for ordered points, ordered pairs or ordered points in one plane, the domain plane, over to the range plane, which indicated by ANT, short for abbreviation for Antwort, German for answer, the answer plane. Okay, so any applied function would distort the plane, and we could indicate that somehow by shading or something. We could reapply or iterate the function on the answer plane to get yet another answer plane, and so on.